Indeed, yeah, it's full screen and looks good. Please go ahead.
All right. So, hello everyone. We are Team Brainwave, and these are our members, and we're excited to present our project. So, our aim is to leverage users' brainwaves for computer interactions. Imagine a scenario from the picture that I present to you guys, where a person is looking at the screen. We can also capture the signal when the horizontal row of the V column lights up. By going through the horizontal row and vertical column, we can locate the row and the column where the V is lit. This way, we can determine that the person is staring at the letter V and identify the number associated with it. So to summarize, our headgear collects brainwaves from 8 channels while the user starts at a flashing or non-flashing point on the monitor, resulting in the different recorded brainwaves. The core idea is to translate these brainwave signals into communication output. As each letter flashes, the system monitors for a specific brainwave response. So when the desired letter flashes, a P300 wave is generated, indicating the user's selection. The system then interprets these brainwave and highlights the chosen letter, allowing for communication. So these are the diagrams illustrating the working process of the P300 system. And the data we've gathered shows 2 categories. As you can see at the top one, the blue colored is a positive sample and the red colored is the negative samples. So analyzing the data from the 8 waves that we mentioned, we observe positive stimulus at 600 milliseconds. As you can see at the very bottom, there's a green line, suggesting that the subject is looking at the targeted number or object.
Okay, and in the following part, I'm going to talk about the 4 methods for training the model. And as you can see on the screen, there are SVM, CNN, DNN, and XGBoost. So here are the results of using different kind of methods here. So as you can see that the conclusion is that CNN gets the highest AUC accuracy and F-score. So because we know that CNN is one of the best, so I'm going to talk about the code and key functions. And in the whole code, there are 3 important functions. The first one is data process train, and the second one is about the data process test, and the last one is about the model CNN. And the second one and the first one about data process are just data process for training. And one of the most important part is in the last one is about the model CNN. We implement how we use CNN for training model here. So here's the results and outcome. We use 3 different kinds of evaluation criteria to evaluate the method. So as you can see, no matter it's in AUC, accuracy of or F-score, and you can see that CNN definitely always get the highest score. And here's another outcome is about the training progress graph. And one of the most important part is you can see that the loss is decreased gradually and the accuracy is gradually increasing. So I think that's one of the great situation. So our reflection is the first one is selecting a compatible training model, and the second one is fine-tuning. The last one is participants on comfortable factor. So here are our conclusions. The first one is about the model effectiveness. And as you can see, the accuracy of the standard model is roughly about 90%, but ours is a bit higher at 91.5%. And the second one is about the future. We just wish that we can use more data to make the model even more accurate. And the last one is about the application fields. We're really excited about the field can use as medical, education, work, etc. Because we definitely believe that BCI is one of the best way to connect the world. So we're really excited when doing this project. And you can see that here are our group pictures and our members are all on the screen. And here are some references. And I think that's all about today's presentation, and I hope you enjoyed the presentation today.
Thank you very much for a nice presentation. Susan, any questions for them?
Yeah, thank you for a very nice, succinct presentation. Well done. And you look like you had a good result. You're excited about medical applications. What would be the first condition you would want to apply this to?
Okay. because we now have some different kinds of programs now, and we all know that the elderly people in Taiwan is one of the most important issue, and some elderly people cannot really talk. So if we can make this possible for the elderly, and I think it will definitely reduce the connection difficulty between the nurse or the doctor, between elderly or their family. So I think that's one of the best way that we can implement it.
Has anybody compared the accuracy of these kinds of approaches using EEG with the actual ECOG arrays or anything?
Sorry, can you say it one more time?
Oh, do you know of any work where anyone's compared the prediction that's possible with this this kind of communication prediction from an ECOG array versus the EEG? Do you think we'd ever be able to approach that kind of accuracy?
Maybe I can jump in. It's much faster. So it's slower. 1 character per second, roughly.
Okay. Cool.
Thank you very much.
For your question for a while. Sorry. So right now it's still no. So forgive us.
No problem.
All right.
Thank you very much for a nice presentation and staying up so long.